Morning students, today I am going to discuss the magnetic effects of current, in which first I am going to discuss the Oersted experiment. Oersted in 1820 found experimentally that a magnetic field is established around a current carrying conductor, just as it occurs around a magnet. His experiment is shown in figure. A conducting wire is connected to the poles of a battery through a key. The wire is kept above a magnetic needle parallel to it. So long there is no current in the wire, the magnetic needle remains parallel to the wire. As soon as the key is pressed, you can see in diagram 1, the needle is deflected, and in second case, if the direction of current is reversed, the needle is deflected in opposite direction. The deflection of needle indicates that with the passage of current in the wire, a magnetic field is established around it. On increasing the current in the wire, the deflection of needle increases. This experiment shows that the magnetic field is produced due to the electric current. Since electric current is charge in motion, it is concluded that moving charge produces magnetic field in the surrounding space. Now, magnetic field is a vector quantity, so we need to find the direction of magnetic field also, for which we have three laws. The first is Ampere's swimming rule, or also known as snow rule. Here in the diagram you can see, if you imagine a man who is swimming in the direction of current from south to north facing a magnetic needle kept under him such that current enters his feet, then the north pole of the needle will deflect towards his left hand, means towards west. This rule is known as snow rule. Here S stands for south, N stands for north, O stands for over, and W stands for west. Now for determining the magnetic field, direction of magnetic field, we have another law which is known as Maxwell's corkscrew rule or right hand screw rule. It states that if you hold the screwdriver in the right hand and rotate it such that the screw moves in the direction of current in the conductor, then the direction of rotation of thumb will be the direction of magnetic lines of force. Now we have another law for calculating, another rule for finding out the direction of magnetic field, which is known as right hand thumb rule. According to this rule, if we grasp the straight conductor in our right hand such that the thumb points in the direction of current, then the fingers curl in the direction of magnetic field with the fingertips pointing along magnetic field. So these are the three rules used to determine the direction of magnetic field. Now our next topic is Biot Savert's law. Biot and Savert performed a series of experiments to study the magnetic field produced by various current carrying conductors and formulated a law to determine the magnitude and direction of field so produced. This law is known as Biot Savert law. It states that the magnetic field at a distance r from a conductor in which current I is flowing is directly proportional to the current flowing through the conductor, is directly proportional to the length of the element, is directly proportional to the sine of the angle theta between the length of element and the line joining the element, and it is inversely proportional to the square of distance r between the element and the point P. On combining all these four rules, we will get dB is directly proportional to ideal sine theta upon r square, or dB is equals to mu naught upon 4 pi ideal sine theta upon r square. In vector form, it can be written as dB is equals to mu naught upon 4 pi ideal cross r upon r cube. The direction of magnetic field at point P can be calculated by the rules discussed above.